All right, okay. And for this molecule, okay, so yeah, we need to give cis trans assignment for cis double bond and also steric center assignment for this the steric centers, okay. And but when you name it, okay, so at the beginning, okay, so you don't need to worry about the stereochemistry, okay, just do the regular thing you did in chapter 5 and also chapter 12, okay, try to give a name for this molecule, okay. So we have methyl, arcane, and nitro, okay, methyl, nitro just kind of only as prefix, okay, cannot add the suffix, okay. So this compound will name based on alkene, okay. So alkene, we try to give you alkene low number 1, 2, 3, 4, 5, okay. So that should be the pentene. All right. So we need to give the theta bond location numbers, okay. So we put the 5 here. Should be 2, okay. And the 2 in, okay. You can also put the 2 before the pentene, and that's also fine, okay. All right, and then we take off the methyl and also nitro, okay. So alphabetic order, okay. So that should be the 3 methyl, 4 nitro. There's no space between kind of the O and the P, okay. The same words, okay, one word, okay. All right, so now we need to take off the stereochemistry, okay. For this cis double bond, okay, so we need to compare kind of the higher party group, okay, higher party group, okay, so the last higher party group on the left carbon, on the right carbon. For the right carbon, okay, so this is the higher party group, okay, so that's we see they on different side of the cis double bond, okay, so that's we through E, okay. Right, and then for the cis for this their center, okay, this one, okay. And so you need to keep in mind, okay, so the hydrogen, there's hydrogen, okay, actually kind of point towards you, okay. Okay, so the lowest priority group point towards you, okay, so that's keep in mind, okay. And then we design the priority, okay, for other 3, okay. Nitrogen has higher priority, okay, and then followed by this carbon, okay, because this carbon has 3 carbon attached to it, okay, 3, 2, and then 3, okay. And when you draw the arc, okay, so 1, 2, 2, 2, 2, 3, okay, so looks like clockwise, okay. But the lowest priority group, the hydrogen point towards you, okay. So we learned how do we handle this situation in the class last Friday, okay, last Monday, okay, okay. We just give opposite assignment, okay. So looks like clockwise, okay, but here we should give the ice assignment, okay. Right, and then once it's done, okay, so we put here the stereo assignment for these 2, okay. So before the parent name, okay, so that will become ice E, okay. And then putting kind of the parasitic, okay. And so you don't need to give a location number, okay, because only one steric center and then 1 double bond, okay. But if you want to put the 4s 2e, okay, and then 3 methyl 4 nitro pentene 2 in, okay, so that's fine, okay, so no big deal, okay. And for the quiz later, okay, so there's kind of cis trans you need to give kind of easy assignment, okay. When clockwise, that's right, okay. Clockwise, okay. Suppose be the R, okay, but the lowest priority group, okay, point towards you, okay, point towards you, okay. We have to give opposite alignment, okay. Opposite alignment, okay. So if the hydrogen point away from you, give kind of R assignment, okay. All right, okay. So for quiz later today, okay. So for the cis trans, okay. So there are some naming questions, okay. So you need to give easy assignment, okay. But I remember there's no steric center, okay. But if there's steric center, okay, so in the quiz, okay, so you don't need to give RS, okay, because that's only cover chapter 6, okay. Right. Okay, and so there are situations, okay. So the compound has more than one steric centers, okay, chiral centers, okay. So in this case you have to give the RS assignment for all steric centers, okay. Example showed here, okay. So this molecule already give you the 2,3 dibromo butene, okay. So and then you only need to care about kind of these 2 steric center assignment, okay. So we have 2 steric centers, okay. All right, and then for carbon 2 should be R, okay, and then carbon 3, okay, should be kind of also R, okay. So and so for this the compound, okay, so the full name should be the 2R, 3R, okay. So you need to give location numbers, okay, location number for both the steric centers, okay. So 2R, 3R, okay, connected by comma, okay, and put in parentheses and then linked by the hyphen, okay, and then followed by kind of 2,3 dibromobutene. All right, okay. So that's yeah, how do you name a compound with multiple steric centers, okay? Okay, so now you guys take practice, okay? So we have just two practice, okay? So one compound like this. So that's the fluorine, okay? Another compound, okay, so it's a chair conformation of cyclohexene. All right, try to give their full names, okay? And then all the steric center, okay? Yeah, if someone like it, I can also put answer in the chat window, okay? Put in the answer in the chat window, okay? Yeah, when are you working on this question, okay? So these two questions, okay? So a couple of things, okay? So first, keep in mind the chapter 6 homework is due tonight, okay? So make sure the smart work online homework, okay? So make sure complete homework by 11:59, okay? And quiz 6, okay? So quiz 6, okay? So I will open it at 1:20, okay? So 1:20, okay? And then you guys have 30 minutes, okay, to finish the quiz, okay? So the due time is 1:50, okay? And I will keep my Zoom open, okay? So if any problem, okay, so just log in the Zoom, okay? And so like this morning, some student kind of cannot open the quiz, okay, or some student kind of cannot hand in the quiz, so I don't know why, okay. And so 30 minutes should be enough, okay, because the quiz I developed based on the previous kind of quiz, okay, so that's like maybe 3 or 2 years ago, okay, so still based on the paper-based quiz, okay. So at that time, okay, so I gave 20 minutes here for students for take the quiz, okay. So now I give you 30 minutes, okay, so should be enough, okay, so for you, work on the quiz and also even take the picture and upload online, okay. And so the due time again, okay, 1:50, okay. So if we pass the due time, okay, so 1 minute late minus 1 point, okay. So 1 minute late, 1 minus 1 point. Like this morning, couple of students kind of 2 minutes or 3 minutes late, okay, that's you lose 2 or 3 points, okay. Yeah. And one thing I have to say here again, okay, so I'm sorry, okay, no cheating, okay. So based on last year experience, okay, so if I use the paper-based exam quiz, okay, so for kind of online the quiz exam online class, okay, so there's a significant increased number of cheating, okay. So if there's a cheating, okay, so no matter who copy who, okay, I will give you 0 to both, okay. So even you copy only one question, okay, so and so please work on the question by yourself, okay, so independently, okay. And actually the in quiz 3, okay, so I already found someone cheating, okay. I gave them the 0 in quiz 3, okay. Yeah. Okay, so please be honest with you the exam quiz, okay. All right. So anyone know the answer for this two, okay? All right, okay, so looks like hard one, okay. So in this case, I will go to work on these two questions, okay. First one, okay, so we have fluorine and also methoxy, that's ether, okay. Both only work as prefix, okay. So that means this compound, we need the name as kind of cyclo, pentene, okay. So very beginning, don't worry about kind of stereochemistry, okay. And then second case, so we need the give stereo give kind of the prefix name, okay, for these two guys, okay, and also the wrong number of the ring, okay. All right, so number of the ring, okay, so just two disubstitute the cyclo, the alkene, okay, so we give low alphabetic order, lower number, okay, so the fluoro kind of start with fluoro F, okay, so methoxy start with M, okay, so that means the fluoro will kind of cover one, okay. Okay, so that will become the one fluoro two, okay, so this one we call the methoxy, okay. Cyclohexane, okay, one fluoro. All right, in the case, so we need take off the stereo center alignment, okay, there are kind of two chiral center here, okay. And for the fluoro, okay, so Okay, so that's one thing. Just keep in mind, okay, because floor going down, okay, so that's means here the hydrogen kind of going up, point towards you, okay, hydrogen point towards you, okay. Same thing for these chiral centers, okay. And so then when you design kind of here the chiral center, okay, so you still control the R, okay. So looks like a 1, 2, 2, 2, 2, 3, okay. So looks like a counterclockwise, okay, but the hydrogen point towards you, okay. So that's you need to give opposite assignment, okay. So that should be R, okay. Same thing here, okay. So yeah, when we draw the arc from left, from highest one to the second one to the third one, okay, looks like here the clockwise, okay, but the hydrogen point towards you, okay. So the real assignment should be S, okay.
All
right. So question, okay.
With your dumb little face. What are you doing with that dumb little face, baby? Why is it so stupid?
Rosie, your mic's on.
All right, any question, please type in the chat window. Okay? Otherwise, yeah, please hit the mute your mic, okay? Please mute your mic, okay? All right. Okay, so yeah, so for this compound, okay, so yeah, the full name should be the 1R2S, 1-fluoride, 2-methoxycyclopentene, okay? Yeah, don't forget kind of give their location number for the two steric centers, okay? Okay, and then we move to this guy, okay? So that's the cyclohexene, okay? So there's one tips for you guys, okay? So whenever you see this kind of chair conformation, okay? So you can convert to a wedge dash structure, okay? So that's much easier to name it and also the design stereochemistry, okay? So for here, okay, so yeah, just see a wedge dash, okay? So bromine going up, that means see a wedge bond. And then chlorine going down, that means see the dash bond, okay? Okay, so for this compound, okay, we still will name based on cyclohexene, okay, because bromine chloride is the only prefix, okay. So that's should be the cyclohexene, okay, cyclohexene, okay. So yeah, similar thing to the first example, okay. So remember it, okay, give you lower alphabetic order, atom lower number, the bromine will be 1 and the chlorine will be 2, okay, and then that puts them kind of alphabetic order before the parent name, okay. That should be 1 bromo 2 chloro. Okay, there's no space between O and C, okay, so it's gonna put a little bit far away, okay. That's yes, one word, okay. Okay, in the case we need to give RS assignment, okay. And so yeah, that's actually not hard, okay. So yeah, for the top carbon case, so the hydrogen point away from you, okay. When you draw the R, okay, 1, 2, 2, 2, 2, 3, okay. So yeah, actually kind of this one. This is 2, okay, 1, 2, 2, okay, and then 2, 2, 3, okay. So that should be the clockwise, okay. So that top one should be R, okay. And for the bottom one, okay, so yeah, be careful, okay. So yeah, because the chlorine connect by the dash bond, okay, that means the hydrogen connect by the wedge bond, okay, hydrogen point towards you, okay. All right, so when you draw the kind of arc, okay, 1, 2, 2, 2, 2, 3, okay, looks like counterclockwise, but because the lowest party group point towards you, okay, so you need to give opposite of alignment, okay, that should be R again, okay. Okay, so for this compound, okay, so the full name should be the 1R, 2R, okay, and hyphen and hold it, okay. So that's how do you do it, okay. All right, okay, so yeah, we already talked about kind of enantiomers, okay. So enantiomer are two stereoisomers, mirror imaging to each other, but non-superimposable, okay. And once you understand what's the enantiomer, okay, so it's not hard to understand the diastereomer, okay. So diastereomer, okay, so yeah, first has to be two, okay, has to be two stereoisomers. So the stereoisomer, we already know that kind of same connection but a different pointing, okay. But the non-mirror imaging to each other, okay. Stereoisomer, non-mirror image, okay. So we already learned the one diastereomer, that's alkene cis trans, okay, isomer, okay. So that's trans, cis, okay. So these two, okay, are stereoisomer to each other first, okay. We know that, okay. So because of the same connections, okay, just here one bond going up, one going down, this one kind of going on same direction, okay, so that's here the different pointing, different arrangement of here a bond, okay. And then yeah, they are not mirror image, okay, so definitely, okay, so not mirror image to each other, okay, so yeah, stereoisomer to each other, but not in mirror image, okay, so that's we can call yeah diastereomer, okay, so yeah. So there are another type of diastereomer, okay, so yeah, as happened to molecule with multiple stereocenters, okay, so then also show the diastereomers, okay. Okay, so here are some examples, okay. So they see a full molecule, okay, yeah, each has two stereocenters, okay. These two stereocenters have two different have a different attachment, okay. So yeah, the top one has bromine, chlorine, hydrogen. The bottom one has the OH, methyl hydrogen, okay. So yeah, all these four have these two stereocenter, okay. But the little bit different the orientation for the attachment, okay. And then if you take the second look, you can find okay. So yeah, for two stereocenters, okay. So maximum you can have the totally full stereoisomers, okay. Because the one stereocenter you can RS, okay. Another center also RS, okay. So that's you can have RRSS, RSSR, okay. Totally full stereoisomers, okay. And we can design, okay. So that's easy, okay. So now it's clearly, okay. So RR will be enantiomer to SS, okay. So because they are kind of mirror imaging to each other, okay. Same thing, okay. So RS will be mirror imaging to SR, okay. So you can see kind of reflect, okay. So exactly kind of match, okay. So they are enantiomer to each other, okay. All right. So now comes question, okay. What's the relationship between 1, 3, and 4, okay? And also 1, 2, 3, and also 2, 2, 3, and 2, 2, 4, okay. So you find that for example 1, 3, okay. So one stereocenter they have same alignment, okay. So the top one, okay, here and here, okay, R, okay. And then for bottom one, okay, opposite alignment, okay. Some same, some the different, okay. So then we come to the diastereomers, okay. Okay, yeah, stereoisomers, okay, enantiomer 1, 2, and then 3 and 4, okay. And then for 1 and 3 and then 1 and 4, okay. So that's we call the diastereomer, okay. Some stereocenter have same alignment, okay. Okay, same alignment for the bottom one, okay, here, okay. And then some stereo opposite alignment, okay, opposite alignment here, okay, and opposite alignment here, okay. And then that's we call the diastereomer, okay. And same thing, okay. So for 2 and 3 and then 2 and 4, okay. So that's we call the diastereomers, okay. Yeah. So for you guys, so far probably you can write it down, okay. So so diastereomers, okay. So some the chiral center are same, okay. Some chiral center, okay. So chiral carbon, okay. So we can call chiral carbon, okay. Opposite, okay. Then we generated the diastereomers, okay. So for enantiomers, okay, so all stereocenters has to be opposite, okay. All chiral carbon, okay. Opposite, okay. So opposite assignment, okay. So R become S become R, okay. All right, okay, so that's I guess we can stop here, okay, because this morning the class also stopped here, okay. So any questions? All right, so if there's no further question, okay, I will turn on the quiz, okay. So this morning the student choose the quiz 4, okay. So in this case, you guys gonna need to work on the quiz quiz 4A, okay. You guys will work on the quiz 4B, okay. So I will turn this one on, okay, and then turn this one off. All right, okay. So now you guys can work on quiz 4, okay. If you have any question, okay, please log in the Zoom, okay. I still keep my Zoom open, okay.